Hello everyone. In this video we're going to be finding the real solutions of an equation in two variables. Now we're not looking for integer solutions, let me make that clear. This is not a Diophantine equation. We are looking for real solutions. It might turn out to be integers at the end, but we don't know that yet. And we only have one equation. So we have to use something special, and I'm going to be presenting two methods here. Let's start with the first method. Now, for the first method, I'm going to multiply both sides by 2 first and get rid of the fraction. Okay. And then let's put everything on the same side. And when I do, I want to write the 2y squared first, and then minus 2y plus 2x squared minus 2x plus 1 equals 0. Hopefully at this point you can see what I'm trying to do. I wrote this as a quadratic equation, or this can be written as a quadratic equation in y. It could also be written as a quadratic in x. As you can see here, it doesn't matter which one you choose because of the symmetry. So I'm going to choose y and solve this as a quadratic equation. How do you solve it? Using the quadratic formula, of course, right? Well, we can write this as y equals negative b, 2 plus minus the square root of b squared minus 4 times a times c. C is the constant term. In this case, anything in terms of x will be considered constant because this is a quadratic in y. And you know why. All right, the whole thing divided by 4, 2 times a. Let's go ahead and simplify this expression. 2 plus minus the square root of. Okay, so I have an 8 here. I can just go ahead and distribute the whole thing. And negative 8 will be multiplied by 2x squared. So that's going to give me 4 minus 16x squared plus 16x minus 8. That's my radical divided by 4 again. Now, what is so special about this radical? Okay. Well, it is a interesting radical because it is a perfect square. Well, pretty close. Not quite, but it is related to a perfect square. So let's go ahead and write this as y equals 2 plus minus. Now, I can work with the expression inside the radical. I can kind of pull out a 4. Actually, yeah, let's just pull out a 4. That gives me negative 4x squared plus 4x minus 1. Not a negative 4, but just a 4 because I want to pull out a 2 here, so I can do that. And inside the parentheses, I can write this expression with a negative sign in front of it, so negate everything, and you can write it like this, all right? And then the whole thing is divided by 4. Now, as you can see here, you can simplify this, but let's go ahead and focus on what's inside the parentheses first. What's inside the parentheses is a perfect square. So this is actually the opposite of a perfect square. Opposite perfect square. Okay, whatever you want to call that. But that's significant because no square can be negative in the real world. So we're basically saying that, okay, what happens if this expression, the discriminant, right? You obviously want the discriminant to be greater or equal to 0 because we're looking for real solutions. And this would imply that the quantity 2x minus 1 squared is less than or equal to 0. But something squared cannot be negative, therefore it has to be 0. This means that x equals 1/2. In other words, the discriminant needs to be 0. And this gives us x equals 1/2 as well as y equals 1/2. So that gives me two solutions, one solution as an ordered pair, obviously. This basically gives me 1/2, 1/2 as the solution to this equation. But wait, there's another way to approach this problem. Let's go ahead and take a look at the second method. Okay, here's the second method. The second method kind of involves putting everything on the same side pretty much. You know, let's do that. All right. Now, instead of multiplying both sides by 2, I want to multiply both sides by 4 this time. You'll see why. And when you multiply 4 times 1/2, it is a 2, right? Okay. Now, 4x squared and 4x, when they appear together in an expression, you can almost guarantee that you're dealing with a perfect square. So this method is kind of like similar to the first one, but it's a little different because we are not using the quadratic formula. We're kind of completing the square here. And we're not really choosing y over x or vice versa. Anyways, so here's what I'd like to do. I want to put these two together and just add 1 to it. And then I want to put 4y squared with negative 4y and add 1 to it. Now the left hand side is balanced because 1 plus 1 is equal to 2, so we're all good. And the right hand side is equal to 0. Now, if you look at this expression carefully, you're going to notice that the left hand side can be written as 2x minus 1 quantity squared. And this expression here can be written as 2y minus 1 quantity squared is equal to 0. Now we have sum of 2 squares and that's equal to 0. It just implies that both of them have to be 0. So this is 0 and this is 0. Otherwise, you can't add a positive and a negative to get 0 because something squared cannot be negative in the real world, of course. We're not talking about complex numbers here. By the way, can you find complex solutions to this? Of course you can. And there are very many, right? Anyway, so this gives us 2x minus 1 is equal to 0, which means x is equal to 1/2. And 2y minus 1 equals 0 gives us the same thing, y equals 1/2. And this brings us to the end of the second method, which brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.